This is a so-called dry cell. With this simple device, we can fission water into oxyhydrogen gas. The electrolysis of water was a simple discovery known to many ancient cultures. Today, it is much more efficient than Michael Faraday's first experiments were 200 years ago. We'll show you how to build this device from materials available at a local hardware store. Oxyhydrogen is eco-friendly and easy to produce from pure water. It produces 3 times more energy than crude oil or gas. It even stores more energy than you need electricity for the electrolysis. This energy is already stored within the water. Water is full of energy. This is why we drink it. So electrolysis is just a stimulus to the water, like the spark of a lighter, like the cranking of a motor, or like a skipper on a yacht setting sails. They all just unleash other, more powerful forces of nature, as we will show you here. This is not a closed energy cycle, so there is no violation of the energy conservation law. The dry cell's function is as brilliant as it is simple. All you need is some mild soap suds and electricity, preferably from solar or wind power. We can use this technology for heating, welding, and even for driving cars. Water is full of energy, and we believe it is more eco-friendly than gas.
Wir schaffen den Himmel auf Erden.
We can create a heaven on earth. That's why we are here. And we are privileged to be able to present this openly. This is a blessing. A warm welcome to you all. I am very excited to share this together with you. You are pioneers. This is all brand new. Well, not exactly. The invention itself has existed for more than 100 years. But it fell into obscurity, so I didn't really invent anything as such. I just did some research. 3 years ago, this device came out of the United States. In Europe, there was nothing like this. I first built this device for myself. As you can see, it's just some steel plates. The idea is that here are the power connectors, plus and minus. Many hobbyists even installed this into their cars. But this device is dangerous. There are 1.5 litres of gas inside. And if just a spark were to ignite this somehow, it could easily then, boom, there would be an explosion. So I've just shown you this prototype as an example of what not to do. Don't replicate this. The principles behind this model are dangerous and inefficient. It also produces only a very small amount of oxyhydrogen. So I put this aside as I didn't want to kill myself, and I soon found another concept. And this is it, the so-called dry cell. The name is quite irritating because it's not actually dry. It just uses very little water when compared to the Faraday-type wet cell. The major difference is that here we have lots of stacked steel plates, but each is separated by a seal. There is very little water inside and also very little gas inside, perhaps 20 milliliters. This is therefore much more efficient and very safe. We always wanted to use oxyhydrogen on demand, and we never store or compress it. Otherwise, it could ignite or explode. Hydrogen is full of energy and highly explosive. And oxyhydrogen is even more so. We know that from school. Does anyone remember the experiments? Put 2 electrodes into a jar of water, connect a battery, ignite the bubbles, and hear them pop. You see it immediately starts producing gas. In the chamber here, the electrolysis of water takes place. The oxyhydrogen is then guided through the siphon full of water, and up here we have the gas. This is called a bubbler. The gas is let through to separate it from water and foam. Oxyhydrogen is incredibly volatile. It diffuses right through everything. For example, a steel container is like mesh to oxyhydrogen, and it's very impractical to store. So we don't store it, and we don't compress it. The idea is instead that we produce it on demand and immediately use it in the quickest possible way. This way, we stay safe. As soon as I switch this on, you can see the oxyhydrogen bubbling up from the water. It goes through the storage and right through the bubbler. There is just a small amount of gas in 3 places in the setup. So here is a quick overview about what is happening. This dry cell device makes the oxyhydrogen. This is the refillable water storage, and this bubbler is a safety device. And up here we have the gas. However, before we ignite it, we need flashback protection to prevent all the gas from immediately igniting. Conventional flashback arresters do not work here. Oxyhydrogen is just too different from welding gases. So this is a very simple solution. Here is a copper tube with fine steel wool inside, which must be rust-proof. If it rusts, it shrivels up inside and loses its effectiveness. This steel wool is what prevents flashbacks. I'll just show you how it works. The unusual thing is that the flame can reach temperatures of up to 3,500 degrees Celsius. Here is a piece of granite stone. And look at what happens. It's not even a second and I can't look at it anymore. It glows incandescent, white hot, and it melts. And if I continued long enough, the stone would drip. It would turn into glass. It is so hot that it just melts into glass. Tungsten melts, titanium melts, iron, steel, everything melts and starts dripping within seconds. Will you pass this around? You can clearly see the surface has become glass on top.
Watch out, this is very hot. Be careful with your camera lens.
I will now try this with an ordinary steel nail. Can you see how it liquefies? And drips. I have no idea what else could make such heat this easily. The craziest thing about this is the flame itself doesn't actually feel that hot. I can even touch the flame. It seems that when the flame comes into contact with different matter, it affects the temperature. So the flame adjusts itself to the matter.